Let's solve some question about exact differential equation. How to solve exact differential equation? Let's learn in a quick way. And the first question, we know that as we explained, the coefficient of the x gives us m and the coefficient of the y gives us, and what's the condition of exact? It was my equal nx. We will search this situation. Derivative of m with respect to y. Here, for x, are there any y? No, it's 0. Minus 2y, derivative is minus 2. And with respect to x. 5y, are there any x? We are taking with respect to x. Are there any x? No, the derivative 0. Minus 2x, its derivative minus 2. They are equal to each other. That's why the equation is exact. What's the easiest techniques to solve exact differential equation? Take integral for each part separately. That is integral of first part and integral of second part. Integral of 4x minus 2y dx, and the other part integral of 5y minus 2x dy. But be careful, first integral with respect to x and the second one with respect to y. With respect to x, 4x squared over 2 will be 2x squared. Minus 2y, are there any term of x? Because we are taking with respect to x, there is no x, it means constant. What's the integral of constant? Itself times variable, that is minus 2yx. And in this techniques, not necessary to put fx, fy, something like that. Just this is techniques, and it shows how to obtain solution of exact differential equation. And 5y with respect to y, 5y squared over 2 minus 2x, we are taking with respect to y, there is no y, that's why it is constant times variable minus 2xy. What's the technique for this type of situation? Write the first integral directly. Let's write the first integral 2x squared minus 2yx plus second integral. But as we write second integral, we must ask this question to ourselves: did we use that expression before or not? 5 over 2y squared, did we use it before? No, we can write 5 over 2y squared. Minus 2xy, did we use minus 2xy? Yes, we use minus 2xy here. That's why you have to cancel. If you use before, cancel. If you don't use, write and finish everything. We finish everything. No extra things, so equal to c. That's it. You can write plus c equal to 0. After that, after finishing all of things, you will equalize the equation to c. Here again, the coefficient of the x m and the coefficient of the y m. Derivative of m with respect to y. Where is the term of y here? The derivative of y 1 times cosine x. We know that if the other variable, as we take partial derivative, if the other variable together as product, we just keep it. We will here focus on the term of y. Term of y here, exponential y, again exponential y, and we keep our other term and 2x exponential y. Derivative of n with respect to x. Here with respect to x sine x. What's the derivative of sine x? It's cosine x. What's the derivative of here in this expression? We just focus on x squared because we are taking with respect to x. X squared derivative 2x, and we keep other one, and 5 is constant, its derivative equal 0. So they are equal again, so it is exact. Again, let's take integral separately. Integral of first part and integral of second part. Sine x plus x squared exponential y plus 5 dy. So here with respect to x, the integral of cosine, we know that integral of cosine, sine, the derivative of cosine minus sine, but integral is sine. So the other term we must keep it, y sine x. 2x, integral of 2x with respect to x, 2x squared over 2, it's x squared. We keep other term because they are together as product. This is important. And continue with second integral. Here sine x we are taking with respect to y. This is important. With respect to y, this is constant because there is no y here. If it is constant, it's self times variable, that is y times sine x, our integral. X square exponential y. With respect to y, we will take integral of exponential y because we are taking with respect to y. We keep x square and we know that exponential y integral again exponential y. We must divide by its coefficient of variable. Here coefficient of variable 1, so no need to write, plus 5 integral will be 5y. And let's write the first integral. The technique says write the first integral, y sine x plus x square exponential y. And as we write the second integral, ask this question, did we use before or not? Y sine x, did we use before? Yes, we used before, and cancel it. X square exponential y, did we use before? Yes, we used before, and cancel this one. 5y, did we use before? No, so we must write 5y equal at the end C. This shows that how to solve exact differential equation in a quick way. And this question is different. Question says that this equation is exact, but there is an unknown function here r. If it is exact, let's find general term of r. If it is exact, we know that this is m and this is n. What we know, the derivative of m with respect to y equal derivative of n with respect to x. Let's take my, the derivative of y equal 1, 2x times 1, 2x. Here derivative of r with respect to y, because we don't know what is r, we are taking derivative of m with respect to y. Here 1 and dr over dy equal derivative of n with respect to x. X square 2x, here x equal 1. The derivative of y with respect to x, there is no x, that's why 0. So 2x removed, dr over dy equal 1. In the first techniques of exact differential equation, we learn how we remove derivative. To find r, we have to remove derivative. We learn to find r, we have to remove derivative. In mathematics, how can we remove derivative? In an easy way, by taking integral. By taking integral, the derivative with respect to y, and the integral must be with respect to y as well. And integral and derivative are removed each other. Here we just have r. What's the integral of 1? It's constant 1 times y plus what we must put, plus c. Now be careful, we did in the first method of exact differential equation, which comes from the definition of differential equation. You cannot put here c because you are taking with respect to y. Are there how many variables that we have? 2. There is x, an extra variable, that is this is not important for us as we take integral because we are taking with respect to y. So the constant part will be for us x term. To show x term, we put f of x. In opposite way, if we take with respect to x, we will put f of y. So as the general term of r is y plus f of x. This is important, and now in an easy way, in a quick way, we know how to solve exact differential equation.